We take raw observations and we up-level those into what we call second-order metrics. So you can do things like you're getting raw location and time data for a rail car, but really what you want to know is what's the dwell time? What's the average dwell time for a rail car? And so we're deriving that second order metric from raw location and time data.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. Today on the show, I'm talking with Jeff Meyer, and he is the CEO of a company called SensorUp. So today we're going to be talking about the spatial Internet of Things, and we're going to be talking about the Sensor Things standard and how this is going to be one of the foundations for the spatial Internet of Things. Just a quick message from me before we jump into the show today. I am constantly looking to improve this podcast. I'm trying to make it better for you, the listener. So any feedback or help you could give me with that would be greatly appreciated. You are more than welcome to reach out to me on social media. You can find me on LinkedIn. Just search for the Mapscaping podcast. I will be there. You're also more than welcome to contact me through our website, mapscaping.com. You'll see a form, an email address there. Fill it out. Get a hold of me, let me know what you're thinking. It would really, really help me out and help me decide which direction to take this podcast in. Okay, that's it from me. Let's jump into the interview. Hi, Jeff. Welcome to the podcast. Thanks for coming along today. You are the CEO of a company called SensorUp, and SensorUp is doing some really interesting work with the spatial Internet of Things. So perhaps before we dive into the nitty-gritty of what SensorUp is up to, perhaps you could just give us a brief overview of what SensorUp does.
For sure. Thanks so much. SensorUp is a geospatial movement intelligence software company that connects people, equipment, fleets in the field to give our customers better operational insights so that they can reduce waste in their processes and work more efficiently. We combine, the worlds of geospatial with IoT and AI to give our customers better insight into their operations and more effective, real-time management of processes.
So first of all, let me say congratulations on the pitch. You've got it down. That was amazing.
Thanks.
You're more than welcome. Hey, so I mentioned this right at the start. I talked about the Internet of Things. You called it IoT. Perhaps before we go any deeper in this conversation, could you give us an overview or a definition of what the Internet of Things is?
The Internet of Things is, the ability to connect low-cost sensors over the internet, track devices, track equipment, track people in real time. There is a real explosion of these low-cost sensors going on right now. There's tons of innovation in the space happening. By connecting all of these, sensors out in the field and in people's homes and in businesses, it's really the next generation of the internet. It's the new ability to track all these endpoints and have them interconnected.
Okay, so again, just going back to the start of the interview, I mentioned a spatial Internet of Things. So that gives the listeners some idea of that there is a location component to this. What other kinds of things are you tracking, and why is location important to that?
We track everything in space and time, and that's the key way that data in our system is tagged and what we think is kind of the key properties, everything that happens from our perspective in IoT and movement intelligence is all keyed on space and time. The other properties that get tracked can be really varied depending on the type of sensor, that's providing the input. So if you're tracking people, it might be body temperature and heart rate. If you're tracking a truck, it's probably direction, speed, and fuel consumption. So it's really very, very, very varied. It allows you to do a lot of different types of use cases and different types of solutions on top of IoT.
So I realize that you're mostly concerned with tracking movement, and we've said tracking already quite a few times in the conversation so far. So it's all about movement. But can we really talk about the Internet of Things? Can we talk about these sensors being connected to the internet and delivering information in real time back to some sort of endpoint where it's collected and processed? Does it make any sense at all to talk about that without talking about location and time?
For certain types of use cases, for certain types of sensors, yes. From our perspective, everything happens in space and time. I guess there's cases where if you're tracking temperature in a home and it's a thermostat, the home is staying in one place, it's not moving around. The location is not that interesting until you roll it up and look at temperatures in homes across the country to say what's the average temperature spend on homes. So to get from a very simple single device use case to multiple devices, you need to have location from our perspective. And where we think it's really the most interesting is when it's assets and things that are moving around in space and time, because that's where we think the real power of IoT comes in.
Yeah, so what I heard you say right then is that spatial, that location is the thing that's sort of gluing things together. So it's giving context to the other sensors, and this is in turn creating the network effect, which is possibly what the Internet of Things is all about. So the more things that are connected, the more things that we can connect through this network, the more powerful the network becomes. But it sounds like this is going to be difficult to do without that location attached to it. Am I in the right path here?
You're very much on the right path. I think when IoT collects data and it doesn't have the context of location and time, the value of that data is significantly lower. And actually, when we start working with customers, in a lot of cases, they don't have good, high quality, location data, and we help advise them on how to make it better. But really, it's my belief that everything should be tagged in space and time, because that context of location and the context of when a certain observation happened is really where you get the most intelligence out of the data.
Okay, so we've established that context is really important here. But another thing I can see that's going to be really important for the Internet of Things, or is right now really important for the Internet of Things, is some kind of standard way of communicating where these sensors send messages that can be understood at the other end. And I realized that the founder of the company has done some work around this. Can you talk a little bit about the standard that has been developed?
Absolutely. So Steve Lang founded the company, and early in the company's history, he worked with the Open Geospatial Consortium, NATO, and the United Nations to create a standard called the Sensor Things Standard. And what that standard allows organizations to do is take very disparate types of sensor data, other types of data that aren't necessarily sensors but can be read in real time, and aggregate that all into a standard format, which is based on observations tagged in space and time. So it's basically a root observation plus space and time. And that, based on that standard, we're able to do a lot of really, really very interesting things, with the data. That standard is being adopted internationally, and what it allows organizations to do, especially in the public safety and military spaces, is combine tons and tons of different types of sensors for different types of use cases and do it across different organizations, because you're using a standard data format that can be read by, lots of different systems. And that's where, the real power of IoT comes in, when you have many, many, many devices connected, and the Sensor Things Standard allows you to do that, because it allows us to convert many different sort of root data formats into a standard format where everything's aggregated and consolidated.
Okay, so I really hope the listeners have a good understanding now of what the Internet of Things is, and these two really important components of it. So the first one, in terms of what you're doing and your work at SensorUp, is definitely location. So that's a location and time. That's the thing that's giving context and allowing these sensor measurements to be comparable to each other. The other really important thing that I can see here is definitely the standard. So again, if we have standards, it means that more things can connect to the network and make the network even more powerful. So increasing this network effect. I think now it'd be really interesting to sort of move on from this and talk about the use cases for us. Do you have any interesting use cases you could walk us through?
Sure, I have a bunch. Let me start with public safety, because that's where the roots of the technology come from and where we, first started working with customers. So in public safety, it's all about responding to real-time events and coordinating that response across police, fire, hazmat, and the different departments. So by adding a number of body-worn sensors to different first responders, connecting them up through an Android smart hub software that we have, and putting them on all the different departments people, we can track police, hazmat, fire department when they're responding to a very large event like a terrorist attack or a flood or a large fire. These are multi-disciplinary responses that need a lot of real-time coordination, and our software has the ability to give them very specific location of where each of their people are, what the status of those people are, what their heart rate is, if they've fallen down. And really what that allows us to do is save lives and make the responses more effective and efficient when they're dealing with these really critical events. And we think that's a really great use case. That market is still evolving, and the sensor technology for that market is still evolving. But we very much, like that space. The more industrial types of use cases that we help with tend to be on the process efficiency and effectiveness area. So we work with oil and gas and mining companies, and we track their people, their equipment, and their trucks when they're driving their operations. And by layering on our geospatial movement intelligence software, we can allow them to run historical reports that show them where the bottlenecks are in their operations. And we allow them to automate steps in the process by detecting certain conditions and using our workflow software to automate the responses to that. So that use case is really about driving more effective and efficient processes in a business. And a really good example of that is we have a customer who spends an enormous amount of money on wastewater hauling. And by tracking the fullness of their wastewater tanks and predicting when they're going to be full, we can send the nearest truck and do just-in-time wastewater hauling, which saves them money because they don't have trucks doing, useless runs and driving by each other on the highway with empty tanks and things like that, because they can automate the whole process using our software. And then, I'll give a third use case, which I think is really interesting, and it's more of a very broad one. We track rail cars across Canada, and we do that in order to, again, detect where the bottlenecks are in the rail network so that we can reroute trains around those bottlenecks and make their logistics more effective. And then the other thing we do for them is we allow them to track where their rail cars are historically so they can check that they are not getting charged demurrage fees, which are the fees that get charged for rail cars sitting on a rail yard. They can check where their rail cars were actually historically in real time so that they know how much demurrage fees they should be getting charged at any given point in time.
Okay, so I just want to try and break this down a little bit, because when we talk about making decisions in real time, making better decisions in real time based on this data that's coming in from the network here, are we talking about like if-then statements? So if the train has been here for more than X number of hours or days, make a decision and action will happen based on that. Is that the kind of thing we're talking about here?
Yes, and I would say more. So we have a few sort of key components to our software. We have the sensor things standard based way of pulling data into our system, which is really core. We have the ability to build second order metrics on top of that and show those in visualizations. And then we have a workflow engine, which is the piece you're referring to. And what that workflow engine allows us to do is build rules or use AI to detect things that are going on in the real world and program responses to them. So we can use business rules or more complex AI to detect things like, if a piece of equipment has more vibration or heat than it has normally, generate a ticket in a field service management system and automatically send a technician to check it out. And we can build those same kind of rules in space and time and, combine geofences with actual, physical things that are getting detected. So the rules can be very, geographically based.
So I want to dive into this data because obviously that's a huge component of exactly what you're talking about there. All of these decisions, these rules, they're all based on data. So let's talk a bit about that. So first of all, about 5 minutes ago in the conversation, we talked about adding sensors to people working in hazardous environments, and I'm assuming, how do you do that? Like, do they just put a sensor in their pocket, or do you have to digitize this in a system somewhere saying this sensor is a human? You know, this sensor is attached here. Do you have to attach them close to each other as well? Because I'm assuming that not every sensor will have a location component, for example. You have other sensors that are specialized in collecting other kinds of data. So how do you combine those? It seems like a bit of a waste of time to me to have every sensor collecting everything.
Like in the case of location, we're actually able to get much better location, much more accurate location data if we're actually using multiple location inputs and combining them. So we'll often do some interesting things around combining, say, GPS data with other sort of location tracking systems, legacy location tracking systems like RFID and things like that. And by combining those, we get a much better, more accurate real-time location than we would normally. Going back to your original question, part of what we offer in our software is the ability to model a person and say, Fred the fireman is the combination of, this heart rate sensor, this body temperature sensor, this location sensor, data coming from his phone, is all modeled in our system as that one person. So that's really the benefit of having software where you can model multiple sensors into a single thing. And we can do the same with equipment. We might be tracking the activities of a pump, but that pump might have tons and tons of sensors on it. We do the same thing. We consider that a pump, and we take all that sensor data, we combine it all in real time so that our customers just see the pump and all the information associated with it. They don't care what sensors it's coming from.
Okay, so you're clustering sensors together in objects and then telling the system this object represents a pump, this is Fred the fireman kind of thing. And then you can sort of track Fred or the pump through space and time.
Exactly. And build business rules that are, around Fred and around the pump rather than it's this individual sensor, that individual sensor, which creates a lot more value for our customers than just tracking individual sensors, in space and time.
Yeah, that makes perfect sense to me. But again, coming back to this data, so it's one thing to collect data and it's a whole nother thing to derive data. And I'm assuming, so if we stick with the example for Fred the fireman, for example, I think that we could probably derive a whole bunch more data from the combination of those sensors.
Absolutely. Yeah. That is really sort of one of the keys to what we do is we take raw observations and we up-level those into what we call second-order metrics. So you can do things like you're getting raw location and time data for a rail car, but really what you want to know is what's the dwell time? What's the average dwell time for a rail car? And so we're deriving that second-order metric from raw location and time data. You might want to derive, cycle time. What's the average cycle time per car? Again, that's a second-order metric that we can produce based on raw location and time data.
This sounds amazing. Previously, you talked about, so looking back and seeing what had happened over the last week, historical data. Can you use that data to sort of model what the flow of the network might look like in the future as well? So it's one thing to look backwards and say, okay, that's the way it looked yesterday. But can you also use it to look forwards and say, okay, so based on the historical data we have, we can expect X, Y, and Z within the next 3 months?
Yes. And that is what we're doing today and directionally where we're very focused. So, we think that one of the keys is the ability to automate your business based on things that are going on right now. But we really think, the future is being able to automate your business based on things that you're expecting to happen in the future and being able to model your business based on those things as well. So we're, directionally investing heavily in AI so that we can do more and more of that
Yeah, and you're touching on one of my next questions here, and that is, what are the really big opportunities in this space? Is there any particular industry which is just sort of waiting for something like this to show up and disrupt it?
I personally like the industrial segments. I think industrial IoT is really going to be a game changer and bring sort of the next industrial revolution. Like, I think the productivity gains that you're going to see in the next 10 years from IoT being adopted in industrial settings is going to be massive. We tend to like industries like oil and gas and mining and industrial rail logistics, partly because those segments have not been as fast to adopt newer technologies, and so there's a really good sort of opportunity for them to invest more in IoT and get significant productivity gains out of it. So we really like the industrial segments. We think they can get a lot of benefit from these new sensors that are coming out, and it's also space and time are obviously very important to their operations. So that's really how we think about it.
When do you think this kind of technology will filter down to the rest of us? When can we expect to see these kinds of sensor networks interacting, being a part of our everyday lives, and I guess eventually in the future also making decisions for us?
I mean, that's starting to happen in the consumer world now. I mean, if you look at Nest smart thermostats and Amazon Alexa and all of these connected consumer devices, those are IoT as well. They're not industrial IoT, they're consumer IoT, but the premise is still the same. You're tracking information about home temperatures and things that you do on your Alexa on a broad network, and you get more value out of that data, and you provide that value back to customers. So it is starting to happen today, and it's starting to add value in our personal lives as well as our business lives. But my belief is that there's this really massive explosion of innovation going on in these low cost sensors, and just the diversity of the types of sensors that are coming out right now is really quite staggering. It's my belief that the sort of pace of change in the next 10 years and the impact that IoT will have on our personal lives is going to be significant. And it's going to be significantly more than the pace of change in the last 10 years because of low cost sensors and because of their ability to really help us in our personal lives and our business lives.
I thought you made some really good points there that I just want to highlight just for a second. When you talked about Alexa and Google Home, so these are smart home devices, and I think it's really, up until now anyway, up until just about 2 seconds ago, I was always thinking of these as I was actually the network myself. So if I brought one of these devices and put it in my home, then that was the network. But when you talk about them as being part of an internet of things as a network, I'm starting to see them more and more as the end nodes on the network, and that Amazon and Google is actually the network, if you know what I mean. That changes the whole way I think about that. Like, I'm a little bit suspicious of these kinds of things anyway. I like to think about it seriously before I'd go out and purchase one and have it in my house. But I think if people started to see themselves or in that light as being the end node in the network, I think that would change the conversation, at least for some people.
And again, it for people, people are always going to have concerns about their privacy, and they absolutely should. But there's a lot of cases where the benefits outweigh the risks or the concerns around privacy. And we're starting to see that change in thinking in public safety specifically, because if you go back, say, 3 or 4 years, your average fireman would have been very concerned about anything that tracked their where they were going and what they were doing, because they'd have potentially legitimate concerns that their employer would be tracking that and measuring them based on it. But that we've seen, more recently that attitude is really starting to change, because firefighters and policemen are starting to understand that it can actually really, really protect them and help them with both their health and safety, because, it allows other firefighters to help them in an emergent event. And it's really about, helping them stay safe when they're in dangerous situations. So in a practical sense, we've started to see firefighters who are actually starting to ask for it now, and they want to see that adoption happen. And I think that's similar in the home. You have to sort of measure the value you're getting out of an Amazon, Alexa, or out of your Nest thermostat, which I personally think is much, much higher than any privacy concerns. But each individual consumer is going to have to make that, that decision on their own.
Absolutely. But I can completely understand with if people get a little bit nervous when they're dealing with these big companies, as well as when they're thinking about location. Like, location is a very personal thing. In a work situation, if I was in a fire, I would love somebody to be tracking me and watching over me and making sure I was okay. I completely understand that use case. I'd like to move on now and talk a little bit about the future. I realize that we've sort of been looking towards that in the last little piece of the conversation, but I've got a few questions here I'm hoping that you can answer for us, which hopefully will give the listeners an idea of where we are with the Internet of Things. So, the Gartner hype cycle. Are you familiar with that?
I sure am. Yes.
Great. So for the listeners out there, the Gartner hype cycle is this curve, and it says there's an innovation trigger. It goes steeply up to a peak of inflated expectations. It drops down to the trough of disillusionment, climbs slowly up what's called the slope of enlightenment into the plateau of productivity. So apparently all new technologies go through this. Where do you think we are on this curve in terms of the Internet of Things?
I think we're actually on the downslope. I think if you look back a year ago in the technology sector and in investors and kind of the hype that's going on around IoT, the fervor with which it was being discussed and the hype around it, I would say was bigger like a year and a half ago. I personally think we're on the downslope, and my view on that is that that's not a bad thing. I actually think it's a good thing, because what it means is we're starting to get to the stage where the technology is maturing. People are starting to understand what it is better. And once you get through that trough, you get into broader adoption. And it's really where that broader adoption happens that IoT's most value gets created, because again, it's like the internet. The more nodes you have on it, the more devices that are connected, and the more access to data you have, the more value it creates. So, my belief is that it's not being as hyped as much as it was, say, a year and a half ago, but that's actually a good thing, because it means that broader adoption is coming just around the corner, and we start to get into maturity and kind of better production business value.
Okay, so we're coming down from the peak of inflated expectations, and this usually just means that people are realizing that this might be a little bit harder than what they thought it would be. Previously in the conversation, we talked about the OGC sensor things standard. How important do you think this is going to be for the future of the Internet of Things?
If you look back at the internet and the internet's ability to gain traction and adoption, it was largely because there were really strong standards around how you formatted documents, how you transmitted, data, how you interconnected end nodes. And those same types of standards need to be applied for IoT to be successful. If everybody does IoT in a completely different way, the value that it creates is significantly lower, because you can't get all those end nodes talking. And without all those end nodes talking, you don't have a complete data set. And that's where, you really create the most value. So we think standards are very important. We're continuing to invest, in developing those standards and promoting them, with our customers and the, partner organizations that we're working with, because it's our view that without them, IoT is not going to, meet the potential that it has.
Jeff, I really want to thank you for taking the time, teaching us all a little bit more about the spatial Internet of Things, the various use cases, and what the future of this might look like. I've really enjoyed the conversation, so thanks very much for that. Before I let you go, where can the listeners go if they would like to reach out to you or learn more about the work that you're doing?
Yeah, the best place to go is to our website. It's www.sensorup.com. Feel free to reach out to me, or our contact information is on there. We'd love to talk to you about, all things spatial IoT related.
Thanks again. Really appreciate it.
Awesome. Thanks, Daniel. Have a great day.
And that's it for another episode of the Mapscaping Podcast. My name is Daniel. It's been a pleasure being your host again this week. If you are new here and haven't not subscribed to the podcast yet, feel free to do so. This is a weekly podcast, so next week there'll be a whole new episode for you to enjoy. All the show notes, links, resources mentioned in these podcasts are available at mapscaping.com. Go along there and check it out. Okay, that's it from me. We'll talk again next week. Bye.